Hello and welcome. This is the rest of section 2.2 or module 4, organizing quantitative data, the popular display. So in this video, I will show you how to construct a stem and leaf plots, or we can call them stem plots. Stem and leaf plot uses digits to the left of the rightmost digit to form the stem. Each rightmost digit forms a leaf. For example, data value of 147 would have 14 as a stem and 7 as a leaf. So the steps to construct a stem and leaf plot are as follows. The stem of the data value will consist of the digits to the left of the rightmost digit. The leaf of the data value will be the rightmost digit. The next step is to write the stem in a vertical column in increasing order. Draw a vertical line to the right of the stem. And the third step will be to write each leaf corresponding to the stem to the right of the vertical line. And the last step is to rearrange the leaf in an ascending order, and then title the plot and include a legend to indicate what the values represent. When our data appears rather bunched, we can use split stems. The stem and leaf plot shown on the next slide reveals the distribution of the data better. As with the determination of class intervals and the creation of frequency histograms, judgment plays a major role. There is no such thing as correct stem and leaf plot. However, some plots are better than others in displaying our data. So in this slide, as you can see, we split the three stem into two branches. The first stem represents the numbers between 3 and 3.4. The second stem represents the numbers between 3.5 and 3.9. What are the advantages of stem and leaf diagram over histograms? Remember how we constructed histograms? We actually can't see the raw data anymore after you construct your histogram. But in the stem and leaf diagrams, you could recover your raw data easily. The next popular display is the dot plot. A dot plot is drawn by placing each observation horizontally in increasing order and placing a dot above the observation each time it is observed. Let's look at this example and try to construct a dot plot. This data represents the number of available cars in a household based on a random sample of 50 households. We want to construct a dot plot. As you can see, we placed the number of cars horizontally, and then each time we observe the value 0, we place a dot. So the number of households that have no cars is 4. The number of households that has 4 cars is 3, and the number of households that have 5 cars is 1. So after we display our data, it will be in a specific shape. We have certain shapes and we identify the distribution as follows. There is the uniform distribution. The frequency of each value of the variable is evenly spread out across the values of the variable. The bell-shaped distribution, the highest frequency occurs in the middle, and frequencies tail off to the left and right of the middle. Skewed right, the tail to the right of the peak is longer than the tail to the left of the peak. Skewed left, the tail to the left of the peak is longer than the tail to the right of the peak. So when you hear the word skew, just think about the tail of our data. And here is a display of the shape of the distributions. So the first one is uniform distribution, and the second one is a bell-shaped. As you can see, it is shaped as a bell. And the skewed right one, the tail is to the right of our data, and skewed left, the tail is to the left of our data. So let's identify the shape of the following histogram, which represents the time between eruptions at Old Faithful. And as you can see, it is almost skewed left, since we can say that the tail is to the left of our data. We will go over this activity in class, but I will show you really quick how to generate 200 integers between 0 and 20. To do that, you pull your spreadsheet and you type in equals rand between. Since we want our numbers to be between 0 and 20, we type in between 0 and 20 and click enter. And then we use the autofill function, which is dragging this square down. Since we want 20 values, so I will use the numbers to help me. we need 200 values, so that is 40 times 5. So I will go down 40. And that is random numbers. And then go up again and go to the side. Five times. And then go again. So I have my random numbers. The last popular display is the time series graph. If the values of a variable is measured at different points in time, the data are referred as a time series data. A time series plot is obtained by plotting the time in which a variable is measured on the horizontal axis and the corresponding value of the variable on the vertical axis. Line segments are then drawn connecting the points. Let's look at the next slide for an example. The data to the right shows the closing price of the Dow Jones Industrial Average, the year 1990 to 2007. This is the year column and this is the closing value. Now, let's draw a time series graph. The horizontal line is going to represent the years, and the vertical line is going to represent the closing value. So the first value from the chart, we can go back. It is 2,753.2. So in the year 1990, it was that value we plotted, and we plot all of those values. And the last step is to connect those dots with the line to create the time series graph. This concludes section 2, module 4 for week 1. Thank you for watching, and I will see you in class.